Welcome to Homework Lib.
Fine, so over here we're asked to tell whether the following structures are identical or enantiomers. Remember that an enantiomer is going to be the mirror image of one of the compounds, and in order to have that, we require the presence of a stereocenter. In this case, both of the molecules are going to have a stereocenter. In this case, this one over here, and in the case of B, this one over here, since all four of the substituents are going to be different. Now, let's look at the difference in between each of them. In the case of A, we have the same connectivity. We're going to have the same substituents on this carbon atom, but what changes is that this hydrogen atom is switched on this scenario. So with this, we can already say that this pair is going to be a pair of enantiomers. For an enantiomer, whenever we switch the position of a pair of substituents while all of the others stay at the same position, then we're going to have the mirror image of that compound. As you can see over here and over here. We can also identify by the order of importance of the substituents being 1, 2, and 3, respectively, which type of compound we're going to get. In this case, the compound on the left is going to be an R enantiomer because of the direction that we're going to have going from one substituent to the other. And in the case of B, let's think that you're looking at it from this point of view. What we see is that the direction goes the other way around. In this case, this would be an S configuration. Thus, these are the R and S enantiomers. Now, in the second case, the only thing that changes over here, we're missing the carbon atom with the three hydrogens. The only thing that we can see is that because of the 3D position that we have, the only thing that changes is that the second molecule is rotated around this axis, since the chlorine atom is now looking upwards and the hydrogen is looking towards us in the second case. So in this case, these are going to be identical structures.